Hi, this is Professor Stugard, and in this video we're going to discuss pivots. So in this video we're really just going to talk about two functions, and you may have seen this if you've taken classes in Excel, because Excel likes to pivot tables too. And there's two options to pivot: the pivot longer and the pivot wider. And we're going to look at examples with both of these functions. So these functions are how we can reshape our data. So given a table of data or a data frame or a tibble, how can I actually reshape the data? How can I physically change the way the data is organized without losing data so that it is better for my different types of interpretations? So we have the pivot longer function, which basically is going to take my data frame and make it much longer, because we're going to use that function when there's columns that really shouldn't be individual variables. If we have columns that aren't actual variables for my data frame, they aren't actually variables that I want to track, I want to actually combine them, all right, and make my data frame longer. Basically squish it down, make less variables, which is going to make my data frame longer. And again, really you want to think if you need to remove any unnecessary columns without removing any data, that's the pivot longer function. The counterpoint to that is the pivot wider function. And this is used when we have an observation, right? We have one observation, but data about that observation is now spaced out over multiple rows. So we have all this data for one observation, but it should really be put together into one, which means we're going to make our data frame wider. We're going to really reshape the data to put the observations all together, which means it's going to be wider. Instead of multiple rows, we need it on one row only. All right. And again, you want to think, all right, do I need to gather these variables together so that my observation all fits on one row? So we're going to do two examples. We're going to do one with pivot longer, one with pivot wider. Both examples, I'm going to use data sets that are actually part of Tidyverse. So if you load the Tidyverse package, you will have access to these data frames. So I would actually suggest that you kind of pause the video, open up RStudio if you haven't already, and actually load up these data sets and do it with me so that you can see the data frames on your own computer screen. You can do it yourself, and you can actually see how the data gets reshaped. Now, the first one we're going to use is the data frame called religious income, or relig_income, right? RELIG_INCOME. So if you load Tidyverse and you start typing that, it should autocomplete, but you type it and you're going to actually see the data frame. And this data frame actually comes from a real poll that was done by the Pew Research Center a little over a decade ago, asking people about what their religious denomination was and their household income. All right, so this is what the data frame looks like in R. So again, if you type religious income, if you have Tidyverse loaded, here it is, boom. And so we see we have the first variable, religion, which has the values agnostic, atheist, Buddhist, Catholic, and so on. So it's in alphabetical order. And then all of my columns would be the income. So do you make less than $10,000? How many people make less than $10,000? How many make between $10,000 and $20,000? How many make between $20,000 and $30,000? And so on. And there's a lot of things that really aren't great with this particular data set. Mainly also being that, see how the gaps change? All of a sudden it goes from $10,000 increments to $25,000 to $50,000 to just over $150,000, which could be incredibly wide. So again, there's a lot of issues with the way Pew did their research here. But we want to actually kind of fix this data frame because there is kind of an issue here. And it's going to start with us asking the fundamental questions: what are our actual variables? What are the variables here? So obviously religion is one, right? You ask a person, what's your religion? And they answer it. Then you ask the person, well, what's your income? Then they answer it. And then they also counted, right? Because they asked multiple people. How many people had that same answer? Well, there's only 3 variables here, which means there should only be 3 columns, because income is spread out over multiple columns. And that's not tidy data. That is not tidy data. That's not how we actually want to store our data. All right. I don't want income spread out over multiple columns. I need it to be one column and one column only, which means we're going to use our pivot longer function. I want to take all those columns and squish them down, collapse them down into just one variable for income. So the pivot longer function, how it works is it's going to take multiple columns. It's going to collapse them into what are called key value pairs. is going to duplicate all the other columns that we don't want to collapse, so it'll keep those all the same. And this is going to hopefully create a tidy data set. So when we talk about the pivot longer function, here are our important arguments to consider with this function. First of all, data. And again, typically we pipe this in, but you can make your first argument data equals and whatever the data set is. The next one is columns. And so we need to specify which columns do we want to pivot, or which columns do I want to collapse. List all the columns that should be collapsed into just one variable. Names2 tells us what's the name of that collapsed variable. So what should the name of that collapsed variable be? And then values2 tells me, well, what's the name of that next column that has the actual data from those collapsed columns. All right. So names2 and values2 become our two new variables, or our two new columns in our reshaped data frame, with names being, again, the names of our collapsed columns, and values2 being the values that were originally there. Now, the last argument you may or may not want to use has to do with dropping NA values. So if you want to drop the rows that have NAs and not include them, you can actually do that as an argument here with the values underscore drop underscore NA. And if you set it to true, it's going to drop it. But again, you may or may not want to do that, but you can, like I said, it's one of those things where you can put it in the function. And if you wanted to drop them, you can do it in just, like I said, the one line of code instead of having to go and do some filters and drop NAs and stuff later on. All right. So again, let's take a look at our data frame for religious income. I want to collapse all of those different income ranges, right? There should not be all separate columns because they're not separate variables. They all describe the same variable, income. So those are the ones I want to collapse. So I want to collapse everything except for my first column, which is religion. And I can actually use that to make my life way, way easier here. So take my data frame and I'm going to pipe it into pivot longer. Again, right? That's like always the first step, right? Take your data frame, pipe it into your function. Columns. So I'm going to do columns equals not religion. And so this means include every column except for the religion column. Because I can do that in this particular case. And that's way more convenient than creating a character vector, right? Where you'd put the C, you put the parentheses, and you'd have to type in every single column that you want to collapse. That would take way longer. This is a much more efficient way to write your code. And it's one of those things that, again, the more you practice R, the more you do things and the more you keep writing code, you'll find these way more convenient ways to expedite what you're doing. But again, it just takes a little bit of practice. So anyway, that is my first argument. My second argument is the names2. So again, I'm collapsing everything but the religion column. So I'm collapsing all those income columns down to, well, income. That's what my variable should be named. So my new column name is going to be income. My values will be the count. Again, right, that's what it was counting. How many people were Buddhist and made between 20 and 30,000, right? It was that number, that count. So I'm going to name my third variable count. So when I run my code now, all right, and I separate each of my arguments with a comma, I keep the religion column, and now income, see now how we have a bunch of different observations. So we have, again, it's in alphabetical order based on religion. So the agnostics who make less than $10,000, they become one observation. So agnostics making less than $10,000, that's observation 1 with a count of 27. Agnostics making between 10 and 20,000 is my second observation, and there's 34 of them, and so on and so forth. So we took this really wide data frame that had many different columns for the one variable income and squished it down to a tibble that has only 3 variables, but now we have 180 rows, which means it's much, much longer than that previous data frame. So again, take a look. Names2, so my new column income, that's going to, the names2 tells me what were my old columns that I collapsed down. So those are my old columns that I collapsed down. And then values2 become my collapsed values. So those values that were stored, again, I didn't lose any data. All my data is still there. All those numbers are still exactly the same. I'm just now calling it the count, right? I'm calling that the count. That's what I named it, and it's those same values. And again, you can go back and forth, like I said, absolutely do this on your own. Take a look at the two data frames, see how the data matches up, see how it moves, see how it's literally reshaping the data. And again, practice this on your own. Now, for the next example, we're going to use Pivot Wider. Again, a data frame that comes preloaded with Tidyverse, and this one's called Fish Encounters, and it tracks fish swimming down a river. The data tracks individual fish. Each fish has a 4-digit identifier. Then we have the station, which represents an autonomous monitor, basically like an RFID chip. Did the fish swim past this monitor? Yes or no? And if it did swim past, it gives it a 1 if it was seen. Otherwise, it does nothing else. So here is what Fish Encounters looks like. So I have a data frame. My variables are fish, station, and whether or not it was seen. And the first thing I notice when I take a look at this is, well, that fish 4842, well, there's a bunch of rows for just one fish. That doesn't make a lot of sense. That fish should really only have one observation because each station should be its own variable. Did it pass through each station? Each station should be a variable here. So I want to pivot this wider. I want to make every individual fish only one row, only one observation for each of the individual fish. So I'm going to take a data frame that's 114 lines long, and again, I'm going to try to pivot it wider. So each fish has those multiple observations, and again, that's the key that tells us we're going to use Pivot Wider. If there's multiple observations, but it's spread out over multiple rows, which is what we have, Pivot Wider is what we want to use so that we have one observation for each individual fish, which now has each station as its own particular variable. And we're going to see when we do this why this might make more sense to kind of look at. So Pivot Wider, very similar. The first argument is the data, and again, typically we're going to pipe that in. Now, unlike having names to and values to, when we pivot wider, it's now names from and values from. So we're working in reverse. So names from tells us the column that we want to look at, and I'm going to choose my new variables based on the values that are in that particular column. And then values from tells me, well, what column am I taking those values from? Now again, this is a data frame with only 3 variables, so it's hopefully fairly straightforward, but again, the idea is that I want to take this column for station, and I want to create my new variables so there's a new variable for each one of those individual stations. So here's my code. So I'm going to take Fish Encounters, pipe it into the Pivot Wider, and again, make sure you're doing this yourself. Names from, so my first argument now, well, I guess technically the second argument after the data, but the first argument in the function now is names from, and it's going to be station. So take all the names from the station, and the values come from whether or not it's been seen at that particular station. And when I run my code, this is what I end up getting. So I see now that each fish only has one observation, right? So fish 4842, there's only one observation, and it goes across, and I see that it was seen at every single one of the stations down the river. And I go through and I can see, all right, was the fish seen at different points in the river? Did the fish not make it to every station? Did it not make it all the way down the river? And that gives us a much better way of actually visualizing the data and seeing, okay, well, what actually happened at each one of these particular stations. All right, so again, play around with these. The questions that I want you to think about here are very general. First of all, describe data that's tidy. We've talked about this before and a bunch, but let's review it again now. When we have tidy data, what does every column represent? What does every row represent? And then each individual value type of thing. All right, what does it mean to be tidy? Then also try to think of a scenario or maybe a data set where it'd be beneficial to make the data either longer or wider. Obviously, you also want to understand the arguments and how we set up pivot longer and pivot wider. And again, this is one of those things where if you have a better sense of big picture type things, this might make a lot of sense to you. How should I reshape my data? If you're not necessarily a big picture type person, it might be a little bit harder. But again, like I said, that's why I chose examples that come in the Tidyverse universe and that you can absolutely do on your own. You can follow along and code along with this video and hopefully see these results for yourself. All right, so that wraps it up with what I'm going to lecture for with pivots. Hopefully we learned something, and as always, take care of yourselves.